Hello all passionate people. Today I'm showing one of my side projects implementing the board game Quoridor with Python for a few reasons. One, I found making it fun. I want to share some of what I learned. And two, finding myself unemployed for the first time, which is hard. But my drive to make things, to invest myself fully into them, doesn't go away. I feel like I should show some, especially those with relevance to my career as a data scientist, data analyst. I'm intending to make this the first in a series of showing more of myself, my challenges and joys, and maybe the people in my life will like it, or at least consider it a worthwhile distraction from doom scrolling on the internet. So first half, showing the game. I'm going to assume you haven't played Quoridor, or haven't played it as a text-based computer game before. So the experience of playing it's important for my takeaways from making it, and then the second half will be under the hood for the programmers, for the detail-oriented people, required a different kind of thinking than I'm used to. And I'm going to talk about next steps to end it, which of course there's more I want to do with it. I want to make all of my stuff available to play online via a web server, but not going to let the perfect be the enemy of the good. The game's in a good working state, so I'll show that. So Quoridor. This is a game with two players, represented by a square and a circle, where you're trying to get to the other side. If you're on top, you want to get to the bottom, and vice versa. You'd think this would be a pretty simple game, though there is one other thing you can do: place fences to block your opponent's path, clear your own path. Just from that one mechanic, some interesting strategies can emerge. Like, let's name our square player Alice and our circle player Bob. I've got custom settings if you want to have smaller or larger boards or a different number of fences, but the default settings are fine. If you're Alice, you can move or place a fence. For our first game, let's just head towards our goal. Let's move up. Bob can do the same, moving down. Even this requires some logics and checks, like you can't move up if you're already on the top row, but we can move down, and I let the user use 2 or down or D as reasonable inputs here. So we're heading towards each other, moving up, moving down. Alice moving up, Bob moving down. Now you'd think a straightforward game like this, going first would have an advantage, right? You'd be one turn ahead getting to your goal if we did the same thing. Well, if you're Bob, if you were to land on top of Alice, moving down, you get to move again. So let's go again down to E6. Now the second player is one turn ahead, and Alice doesn't want to just be one turn behind until she loses, so time to try out placing a fence. So the naming convention's a little bit tricky. It's based upon what's the closest to the top left corner, so this would be fence E7. Horizontal. And then I put in a check if this is not, speaking with computers can be finicky for people, so if this is not what you intended, you can say no and then place a fence somewhere else. But this is what we intended. Bob wants to do something. We can't move down anymore. As we see, the horizontal fence at E7, F7 blocks moving down to E7. But we can move around it. So if we went left, Alice's job is now to slow down Bob, because Bob is ahead right now. So what if we placed a fence at C7, horizontal? So Bob could keep testing this, head a couple moves to the left, but clearly Alice is just going to block his path. So the one tricky rule in this game is that there always needs to be a path to the end. You can't just put your opponent in a box where they can't move and that's the end of the game. So Bob doesn't want to waste turns heading over here just for Alice to block them. So how about we set the fence ourselves? Let's place a fence, if we're Bob, as A7, horizontal. Now we know we are going to the right and down, right? There's nothing, you can't block the whole path, so there needs to be a way to get to the end. So what if Alice was making a break for it now? Let's see, move up. And Bob wants to block her path, similar to how she did for him. So placing a fence at E4 would get that. Well, you would think maybe, instead of the first player having the advantage, the second player has the advantage, because what if we just copy each other? The second player just keeps copying me back and forth, knowing that eventually I'll get to hop over you and I'll be one turn ahead. Well, there are some things you can do from which there is no return. There is no copying that. Once the board is of a certain way, you won't be able to block it on both sides. Like, what if we put fences here? We want to get around. As Alice, we want to get to the top, and Bob wants to get to the bottom. What if both of us need to go up and around clockwise to get, for Bob, that's a longer path for them than it is for me. What if I placed fences here? Like a vertical fence at G4. G4, vertical. Cool. So if Bob was making a break for it, they wanted to head towards, right and down, they would go Let's go right. R. Cool. Well, I'm going to block off this whole part of the board. Place a fence, G6, vertical. Now we both need to take this path, and it's a lot faster for me. I would think at this point, our square player has a pretty decisive advantage. Like, we each have 7 or 8 more fences, we can make our paths winding up and down, but fundamentally, you gotta go all the way around, and I'm gonna at least get to 3, and then you're gonna have to just make me double back a little bit in this area. But that's where the strategy of the game comes from, is that you wanna just place a fence, but you also want your fences to build a shape of the board that ultimately benefits me. So let's show you the win condition here. Bob has to go up and around. They both have to go up, which is good for Alice because that's her goal, but not Bob's. Moving up, and I'll show you some of the last fence logic. Can you place a fence here? G5. Well, here's fine horizontally, but the vertical fence, G5, there's actually 2 issues with that. There's 2 fences that overlaps with. What about placing a fence here, F6. F6. So horizontal is okay because we're between these fences, but vertically I'd be crossing through these planks, so that wouldn't work. So it's been fun to figure out the logic and how to display that in a readable way, despite the fact that the logic is totally different. It's looking at tuples and arrays. That's for the coding part. But Bob is going to spin his wheels as Alice wins. Let's finish it. Moving up. Bob. I3. Sure. Moving up. And we win. Alice won. Lovely. Okay. So how'd we do? Deep breath. Before I show you the code, one last thing on the game. I found Quoridor in a Bay Area bookstore with a friend. We picked it up thinking we'd figure this game out in a few plays, but it proved surprisingly replayable because we assumed at first the first player would have an advantage, but the second player gets to jump over the first player. So if the second player has an advantage, why not just copy what the first player is doing? Well, there's certain moves you make that can't be copied. Eventually, the fences go to the wall, the board becomes asymmetrical, and we're both going the same direction. So we started doing things like placing the fences behind us to say, I'm locking in my progress, you can't send me back that way because I can't go back that way. So it proved a pretty elegant game, and I thought it would be a fun exercise in object-oriented programming to code this. A little trickier than I thought, though, because this is not a board. This is a display of a board, a representation of the board. So the game is essentially just 3 classes: the board, the players, and the game state. So what does the board have? It has a size, it has fence spots, but I see it on the back end as lists and dictionaries. But what the players want to see it as is what looks like a chessboard. So I print, depending on the size of the board, then this as a message to the player, and then populate their marker into the appropriate spot, and then populate the fence markers if I've noted the fence is occupied. So inhabiting the perspective of the developer, but also the user and the tester means doing different things. Like I would like to, as a user, and showing this to other people, refer to the square as A3. That's a rather intuitive way, like chess notation. But I don't want to do string parsing on the back end. I want to be iterating over numbers. And so I would use row column, 3, 1. So letting the player input A3, but turning that into row column, doing the appropriate operation. And if I need to reference 3, 1, I turn it into A3 and then present it to the player. So useful global functions to have. But the player has a name, it has a marker, it has a fence count, but what does it do? Its methods are move pieces, place fences, and then all of the different checks. It's important to not just have something not work, but not offer any feedback. So explaining why you can or cannot do certain things, that's an important part of the user experience to me. But the game takes place over states. You initiate the board and players and associate them with the game. You ask for their names. And this is a very different way of thinking than as a functional programmer, as a data scientist. For people who do lighter coding, you end up doing some of the same things when you're scripting. Top to bottom, you end up bringing data sources in, joining them together, cleaning up data, filtering or extracting features for models, and modeling, and then eventually shaping the data a certain way for whatever output you need. But you would expect the input to be the same, and if so, you go straight down to the bottom as usual. But this game has a state. It is a certain player's turn, and I will keep asking what you would like to do until you make a valid turn. So from the tester's perspective, testing, well, what if I want to place a fence here? Well, that I would actually go off the board, so I need to have a check for that. But once a player successfully moved, then you can mark done turn, and then I've got to hand over change turns. So the start of a turn is asking a player what you would like to do, and then sending them to the appropriate function if they want to do that. But then you have these while loops that keep asking. If you enter nonsense as your input, then it'll go back to the appropriate spot to ask you again, and being able to undo. I feel like that was a very important use case. So I realized I didn't actually use a lot of classes coding as a data scientist, but now I feel like I could. In Delta Airlines, we have these various surveys, and I had different cleanups scripts for each of the different kinds of data inputs, but they became a different script, and I had to maintain each of them, whereas I could have one central pipeline of all of the checks necessary to determine whether this is cleaned data. If it doesn't have headers, give it headers. If it has NAs, remove them, etc. And then it becomes a member of the class cleaned data. And then you can wait until then to shape the data into a table or model or do whatever you're going to do for a particular output. But I could just say, give me my summary stats or my correlation matrix of my cleaned tables, but not this. And the pipeline becomes way more flexible. So it's something I could potentially take with me, as well as all of the logic and the appending the logic. But there's plenty of things I want to do. There's two main ones: is make this so that it's a game playable by any two people in different places online. But I realized the structure of like a web server is different than a local terminal where I can use input messages. That kind of stops things where I need to append everything and give it to the player as a message, and then I need to wait for a response. So I will be restructuring the code, but I was thinking as I got deep into that, might as well show the game as it's working right now, and then collecting log information about the games as they're played, because I want to do analytics. Why not? For everything. So what correlates with wins? Placing fences earlier, just moving earlier. But fun exercise, and I'll show you more of what I'm up to. But like, comment, and subscribe. That's what they say on YouTube. Take care, everybody.